Hello friends, welcome to GT Science tutorial. My previous video was about scanning electron microscopy and this video is about transmission electron microscopy. Transmission electron microscopy is quite similar to scanning electron microscopy, but in transmission electron microscopy we use a high energy electron so that we can get a better resolution. Transmission electron microscopy is a very important method for the characterization of nanomaterials. But before that, if you haven't done it already, please subscribe my channel and press the bell icon so that you will never miss an update from me. So let's start. In TEM, transmission electron microscopy, high energy electron beams are allowed to pass through the sample. This is the basic idea for TEM. In it, high energy electron beams are allowed to pass through or refract through the sample. So this is the basic idea for TEM. The transmitted electrons are projected into the detector to get very high resolution image. In it, the transmitted electrons or the refracted electrons are projected on the detector and analyzed so that we can get very high resolution image. Since electrons are accelerated at higher energy than in SEM, obviously in TEM electrons with higher energy are used, so their wavelength will be lower than in SEM. That results in better resolution. So TEM, that is transmission electron microscopy, is a better way to get an image of the sample. Now let's study about contrast modes of TEM, that is how do we get the image of the sample. In it we need to study three modes. The first one is bright field mode, the second one is dark field mode, and the third one is phase contrast mode. First of all, let's see bright field mode. In this mode, thicker region of sample blocks more electron, so fewer electrons transmit and reach onto the detector, making this region slightly darker. These lines try to say that if there is more amount of sample, then they will block more amount of electrons, so less number of electrons will transmit through them, making that part slightly darker. The regions where there is no samples will transmit more electrons and look brighter. If there is no sample, they won't be able to block electrons, so that region or that part will be brighter. Thus, regions having nanomaterial look darker and regions without nanomaterial look brighter. So this is the fundamental for bright field mode. The second one is dark field mode. If a sample is in crystalline form, then it scatters electron beam in some specific directions where Bragg's condition is met. Now remember one thing, dark field mode is only for crystalline formed substance. By placing an aperture on the back focal plane of objective lens, only those electrons that are scattered from the sample can be selected and projected onto the detector. These lines try to say that if we put an aperture on the back focal plane of objective lens, then the scattered electrons from the sample are projected onto the detector. Thus, regions in which sample is present look brighter because they scatter electrons, and other regions look darker because if there is no sample, they won't scatter the electron. Similarly, the third one is phase contrast mode. In this, we calculate the phase difference. This mode is used in high resolution transmission electron microscopy imaging of crystalline sample. This is also used for crystalline sample. The electrons that are diffracted and transmitted from a sample travel different distance to come to detector, so that some phase difference exists between them. Obviously, if there is sample, then they will take more time, and if there is no sample, then they will take less time. If the phase difference is analyzed and retrieved, then a high resolution phase contrast image of the sample is obtained, that is, the topography of the image can be obtained by measuring the phase difference of the electron beams. Now let's see the components and functioning of TEM. The first component is electron gun. Electrons required for illumination are emitted from an electron gun. Here in this figure, this is the electron gun and from which we get the electrons for the illumination. Other components are slit, first condenser lens and second condenser lens. The wide-angled electrons are blocked by a slit and beam size is reduced by using first condenser lens. Now this first condenser lens will reduce the beam size and the second condenser lens focuses the beam to a narrow spot onto the sample. This is the second condenser lens. This will focus the electrons to the narrow spot here of the sample. Now remember one thing, condenser lenses are electromagnetic type. The other component is objective lens. The electrons that are transmitted from a thin sample are collected by objective lens. Here in this figure, this is the objective lens. It collects the electrons transmitted from the sample. Similarly, other components are intermediate lens and projective lens. The focused image made by objective lens is magnified by using a pair of intermediate and projective lens. Here, this is intermediate lens and this is the projective lens. The intermediate lens and projective lens amplify or magnify the image obtained from objective lens. And the last component is detector. The magnified image is projected into an electron sensitive camera to get an image of the sample. In the figure, this is the detector. Now let's see sample specification. That means what type of sample is required for TEM. The sample used for TEM should be thin, otherwise electrons do not transmit. So the first requirement is sample should be thin. If the sample is non-conductive, then it is to be conducted with metallic film to minimize the charging issues and decrease the background. So the sample should be conductive. Now let's see the information that can be obtained from TEM. The first information is shape, size and organization of nanomaterials. They can be obtained from TEM. The second one is crystallographic information such as degree of crystallization or ordering of atoms, symmetry and atomic scale defects in localized area of sample. And the third one is elemental compositional information. So these are the informations that can be obtained from TEM.
Thank you for watching the video and please share this video to all the students and let me know your thoughts in comment section.